Okay, let's do a quick one. Given a triangle array, return the minimum path sum from top to bottom. In each step, you may move to an adjacent number of the row below. More formally, if you're index I on our current row, you may move to index either I or I plus 1. Notice this is kind of like a DP situation, and so if this statement is true, then at index I actually, and then if you look backwards, you can look at index I of the previous row or I minus 1 of the previous row, which is just the inverse of this. Because I goes to I, and then this guy's I plus 1 is this guy's I minus 1. So we're going to just say for I in range 1 to the length of triangle, that for j in range length of I, then I want the triangle IJ equals, and of course I need to do edge conditions. Then because there's no other path that could go there, but if it's like this, I minus 1, then it's actually j minus 1, then actually like this, right? I minus 1 of j. So yeah, I guess when I say j, I really mean I. I is row and j is column. So I mean I here is column, so j here is just column. So you just make that switch. Right, so then here I can look here or here. So I need to take the minimum of just whatever this was, the sum of this and this, or sum of this and this, and then take the minimum of that and then add it to this. So for example, 2 plus 3 is 5, 2 plus 6, or 2 plus 4 is 6, so 5 and 6, the smaller of the two, namely I'm in index 1, so index 1 and index 0 of the previous row, I'm going to take 5, so 5 plus this 5 is good, and then let's say we go up one level, j is 0, so this is just plus equals of this I minus 1, and then the same j, and then this one, j equals this triangle, like the edge, and then we just again take the previous row and then the 0th of the previous row. And then just take the last row and return it. See if this works. Yeah, it seems quite straightforward, and that's it for this problem. Not sure how long it took, but we'll see.